Welcome to the lesson reviewing polynomials and their end behavior. We're going to first start off with some vocabulary around polynomials, and we have here in this very first spot the general form of a polynomial. What's important to notice in this general form is that the highest power is n, and you should notice that the powers are going down as we go across. And that highest power is known as the degree because it determines how fast my polynomial is going to grow. Another term we have is the leading coefficient, and that is simply the coefficient of the term with the highest power. So in this case, it's a sub n. In our next polynomial, our degree is 4 because it is the highest power, and our leading coefficient is 3 because it is the coefficient in front of x to the 4th. Now, it is not always the first term, so take a look at this one. Our highest power is 2, so our degree is 2, and our leading coefficient is -1, since that is the number in front of x squared. In this next one, it's the first term again, because our highest power is 3. Leading coefficient is 3/5. And in our last one, there is only one term, therefore the degree must be 12, and the leading coefficient -3.2. So at this point, you might be wondering why we care so much about the degree. And so we're going to use a little spreadsheet to understand the importance of that. You'll notice in the x column, I'm just going up by ones from 1 to 20. So we can see our growth rate there is always going up by 1. And we're going to compare that to what happens when we square numbers. So I'm going to take each of these x numbers and take it to a power of 2. If I double click here, I get all the numbers. And what you're going to see is an x squared, rather than going up by 1 every time, I go up by 3 and then 5 and then 7, all the way to where I hit 400, a number quite a bit bigger than 20. You can imagine as I approach infinity, this difference becomes even greater. We're going to do the same thing with x cubed. So we're going to do power, and we're going to take this number, comma 3, and take a look at how that grows. To see how fast it grows, I really like looking at this bottom number here where we can see already 20 to the third is significantly bigger than 20 squared or 20 to the first. Imagine how much that difference is as we head to infinity. Same thing with x to the fourth. And we can see again how it grows significantly faster. The whole point of this is when we have a polynomial and we know the degree, that leading term is going to grow so much faster than all the other terms that the leading term determines what happens as you head to infinity, because it essentially leaves the other terms in the dust. They're just tiny little specks compared to the leading term. So when we go to infinity, which is what we're going to be considering next, looking at things like this, when we head to infinity, we're always interested in what happens to f of x. So when we see something like this written in our homework or on a test, we're going to read to ourselves, as x approaches infinity, f of x, which is the same thing as y, or y, approaches, and we're going to answer that question. What is it approaching? All right, so let's look at a couple examples to see how this looks. In here, I have two examples with even degrees. The first one, a degree of 2, and the second one, a degree of 4. And I've got some graphs here we're going to take a look at. So this first graph is y equals x squared minus 4. And so our first question is, what happens as x approaches infinity? So let's take x as it approaches infinity. So we're going along the x-axis, and as x gets bigger and bigger, we can see that our y value also gets bigger, and we'll see that f of x also approaches infinity. If we go in the opposite direction, as x approaches negative infinity, we see that our y values still keep getting bigger, and f of x approaches infinity. Now let's take a look at this next graph for y equals negative x to the fourth. And if we pull this up, we can see that, oh, they don't both go up, they both go down. And hopefully you remember that that's going to be caused by the sign of our leading coefficient. Look right here, our leading coefficient is negative. So in this case, as x goes to infinity, we find that our y values are heading down. So f of x is heading to negative infinity. And as x goes to negative infinity, being an even function, it does the same thing on both ends. So f of x also goes to negative infinity. All right, so these are even degrees, and we see that they either both go up or both go down, and the leading coefficient is what determines that. Okay, so we're going to look at odd ones next, and we can see the degree here is 3, and over here the degree is 5. So let's look at our third degree one first, and we can see in this first one that as x approaches infinity, so is f of x. So as x approaches infinity, my y values are getting larger, but when x approached negative infinity, my y values also approaches negative infinity. And that's because when we take a negative number and cube it, it's going to be negative. Now let's look at this next one. Hopefully you're kind of recognizing what I'm doing here. We changed that leading coefficient instead of being positive over here to being negative. And so we'll see that it does the opposite, that as x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches positive infinity. All right, so on our next one, we're going to just summarize this in general because the same thing always happens in these cases for polynomials. So it's really important to realize that this is specifically for polynomial functions. So if I have a polynomial and I have a positive leading coefficient, as x goes to infinity, f of x goes to infinity, whether it's even or odd. But if it's even, it goes to infinity on both ends. So here's an even one where we're going up on both ends, and anything can happen in the middle here, okay? But if it's odd, it goes in opposite directions. And so here it's going up positive, here it's going negative, and things, whatever happens in the middle. Now, if we have a negative leading coefficient, as x goes to infinity, my y value goes down no matter whether it's even or odd, but the even or odd tells me if it does the same thing. So even functions do the same thing on both ends, odd functions do opposite things. So here, as x goes to infinity, f of x goes to negative infinity, it goes down, it's going to go down on both sides, and then we have something going on in between. Here, as x goes to infinity, y values go down. On the other end, it does the opposite, and anything can happen in the middle. All right. Our last thing we want to do is make sure we understand if I've got a mystery polynomial, I can figure out the degree and leading coefficient. So if I wanted to figure out the degree of this one, I just start counting the changes in direction. So I've got 1, 2, 3, 4, 5. So 5 different directions I was going. So my degree is at least 5. And being odd makes absolute sense because notice that I'm going down on one end and up on the other end. So I was expecting it to be odd. And then my leading coefficient is going to be negative. And the reason it's negative is because as x approaches infinity, so as x approaches infinity, f of x was approaching negative infinity. And whenever that happens with a polynomial, my leading coefficient is negative.